Well, welcome back to another exciting episode on this journey through algebra with Coach Maxwell. As we've been looking through this unit, we've been solving systems of equations. We've been solving these two or more equations that may or may not intersect. We've solved them by different methods. Well, tonight we introduce elimination. So tonight we introduce the elimination method. Now, as we talked about it, we talked about graphing. And you remember, in order to graph them, we had to have both of our equations had to be y equals. And we would take them and both of our equations had to be y equals. So they both had to be in slope-intercept form. We'd take them and we'd graph them and we would find exactly where that point of intersection was. And that worked great. Sometimes, but they weren't both in y equals form. Substitution, we had to have one where we had y equals or one was x equals, okay? So we were looking for that. That was kind of our determining when we would use substitution. So we could use our graphing calculator for if they were both in y equals. If one was y equals or one was x equals, we could use substitution. It was fairly fast. Well, tonight we're going to look at elimination. And elimination happens when we have both, where we have the x and plus or minus the y equals. For both of them, it sets somewhere like that. So we could say it here. I'll say plus or minus x plus or minus y equals some number, okay? So anyway, it's for every other situation. If they're both in standard form, I guess is the best way. So if they're both in standard form, we're going to use elimination. So let's look at them. Now notice here, we've got two of them. They are in standard form. Notice as you look at them, the x's line up, the y's line up, the constants line up. Okay, so that's how we know that we're going to use the elimination method for these. So the important thing is when we look at them, we're looking for what variable can we eliminate. Can we eliminate? Now, we eliminate by either adding or subtracting. Now, as I notice right here, look, I got 6y's here and I got 6y's right here. So that tells me that we're getting rid of the y's first, okay? So 4x plus 6y equals 32. And we've got 3x minus 6y equals 32. Now, so once you've decided on your variable, the next important thing is decide, okay, how can we eliminate this variable? Do we add or subtract? Well, because these two have opposite signs, this one's a positive 6x, this is a minus, they're eliminating already. So we're just going to add these things straight down the board. We're just going to add these two equations right here and see what happens. So 4x plus 3x, that's 7x. 6y plus a negative 6y, well, those eliminate each other. They're gone. Equals, now we got 32 plus 32, well, that's 64. Okay? So, whoops, what did I write 32 for? Hello, y'all let me get away with that. That wasn't a 32, that was just a 3. Looking at that problem over there. Okay, so that changes things. 32 plus 3, well, that's 35. Well, now the rest of the problem works just like substitution. We're going to divide both sides by 7. Find that x equals 5 now. So we've got the x equals 5. Well, how do we find what y equals? Well, we take this back over here and we substitute it in. It doesn't matter which one. Just like in substitution, we just pick one. I don't know. I'll just pick the top one. So we got 4 times x, and x is 5. So 4 times 5 plus 6y equals 32. Well, I guess in hindsight, I should have picked the bottom one. Numbers are a little smaller, but that's okay. 4 times 5, so that's 20 plus 6y equals 32. So we subtract 20 because we're solving for y. Remember, leave it the best for the last. So I got 6y equals 32 minus 20 is 12. Divide by 6, and we find that y equals 2. So y equals 2. That means our solution, we have to write it now. X is 5, y is 2. Our solution is 5, 2. These two lines intersect at the point 5, 2. So there's elimination. There's the first one. They just have to be set in the same form. Like we said, the x's, the y's over, constant, whatever. We've got that, and then we're looking for a variable. So let's take a look at another one. Here again, it's set up for elimination. We've got our x's here, y's here. So it's set up right. Now, next thing we said is we pick which variable. Well, I've got 3x's here, 3x's here, so we're getting rid of the x's. Negative 3x plus 5y. Try to write the equations correct this time. Negative 11. Positive 3x plus 7y equals negative 1. Now, said again now, make up our mind. Are we going to add or subtract? Because this one's negative and this one's positive, they're already opposite signs. We are going to add these equations. Okay? We're going to add these equations. So negative 3x plus a 3x, those two eliminate each other. 5y plus a negative 7 or plus 7y is 12y equals a negative 11 plus a negative 1 is a negative 12. All right. Well, that's pretty easy. Divide both sides by 12, and we get y equals negative 1. So y is negative 1. Now we come back over here, plug it in. I'm going to plug into the bottom one because numbers look a little smaller. Well, at least this one is. So 3 times x plus 7 times my y, which is negative 1, equals negative 1. So 3x minus 7, because 7 times negative 1 is negative 7, equals negative 1. Add 7 to both sides. Those eliminate. Now we have 3x equals negative 1 plus 7 is 6. Divide by 3, we get x equals 2. So our solution, where do they intersect? That's at the point 2, negative 1. There we go. We solved it by elimination. So let's try one more. Okay, so we look at these. X's are lined up. Let me see, our X's are lined up, Y's are lined up, constants are lined up. Okay, so this is set up to be solved by elimination. So when we look at them, which variable to get rid of? Well, 5x, 2x, 6x, 3y. Ooh, not the same thing. However, when I look at them, 6 and 3, those are pretty close. So the only question is, to eliminate, we need the same number. So the first number that 5 and 2 have in common, first number those two are going to have in common is 10. Okay. What about 6 and 3? The first number they have, 6. Okay. So we're going to eliminate the y. So because that's the case, the top one, what do I have to do to get a 6y up here? Well, nothing. I don't have to, you can say we multiply by 1. Sometimes we multiply by 1. We don't change it. The second one, I need to multiply everything on this one by 2 so I can get a 6y. So I know this is probably confusing. Just trust me. Write it down. We will discuss this in class. This is the one you're going to have questions about. So 2 times 2x is 4x plus 2 times 3y is 6y equals 2 times negative 5 is negative 10. So now I am set up to eliminate. Okay, I've got the same number of y's there. So in this case, do we add or subtract? Well, in this case, because this one's positive and this one's positive, if I add them, they're not going to go away. So this time we're going to subtract. We're going to subtract everything. All right, before I freak some of you guys out, you realize that this second equation, if I divide everything here by 2, I'm back to the beginning. So I really haven't changed its form much. But let's go here. 5x minus 4x is simply an x. 6y minus 6y is nothing. Equals negative 8 minus a negative 10. Ooh, be careful. Remember, when you minus a negative, that's a plus. Sign change there. So negative 8 plus 10 is 2. Hey, look. Well, this one worked out easy. X is 2. I know what x is. It's 2. So now I can plug it in wherever I want to. I'm just going to plug into this bottom one. I don't have to plug into the one I changed. I can plug into this one right here. We said before, it doesn't matter which one you plug into, just plug it in. So x is 2, so 2 times 2 plus 3 times y equals negative 5. 2 times 2 is 4 plus 3y equals negative 5. Now subtract 4. Remember, we're solving for y, so we'll leave the best for last. 3 times y equals negative 9. Divide both sides by 3. We find that y equals negative 3. So what does that mean? That means our solution, these two lines intersect at the point 2, negative 3. There is my solution. There is elimination. You've now gone through and learned 3 ways to solve a system. You can solve it by graphing, you can solve it by substitution, and now you can solve it by elimination. So hopefully between those 3, you're going to find one that you were very good at. You can get pretty good at the other 2. You can know when to use them. like I said, bring your questions into class. We will work a lot of these the next week or so, getting you more prepared, getting you a lot better. So have a good evening, and I'll see you in class tomorrow.